Hello everyone, hello again. In this lesson I'm going to explain the accelerated motion. I'm going to explain the meaning of the acceleration, and I will explain several questions related to accelerated motion. And the graphs related to acceleration is going to be examined in the next lesson. So let's start with the definition of the acceleration. Acceleration is the rate of change of the velocity. We define acceleration as acceleration equals delta v over delta t. So delta v is a vector, acceleration is also a vector, and the unit for acceleration is going to be delta v is meter per second divided by time, let's say second, it will be meter per second square. What do I mean by rate of change of velocity? Now assume you have an object, it starts motion from rest, its initial velocity is 0, then it becomes 3, then 6, 9, 12, and it continues like this. As you see, the velocity increases from 0 to 3, the change is 3. From 3 to 6, changes again 3. Here, changes again 3. From 9 to 12, change is again 3 meters per second. It means that the velocity is increasing constantly 3 meters per second. Assume the intervals are 1 second, 1 second, 1 second, 1 second. So this means that the acceleration in this case is going to be 3 meters per second square. Here the acceleration is in this direction and the velocity is also in the same direction. Now assume your car is moving with 15 meters per second, then it starts decelerate. The velocity is decreasing, for example, to 10 meters per second, to 5 meters per second, and decreases to 0. In this case, the change is -5, the change is -5, and change is again -5. So acceleration here will be -5 meters per second square. Negative here shows deceleration. Okay, so it will be better to solve an example related to the accelerative motion. For example, a car increases its velocity from 12 meters per second to 32 meters per second in 20 seconds. What is the acceleration of the car? Now remember, first of all, v initial is given as 12 meters per second, and v final is given as 32 meters per second, and time difference is 20 seconds. And we know that the acceleration, we defined it as delta v over delta t. Delta v means v final minus v initial divided by delta t. So as you see here, the final velocity is 32 minus initial velocity is 12 divided by total time is 20 seconds. So it will give us 1 meter per second square. We can also find the result from our definition of the acceleration. As you see, the acceleration we found is 1 meter per second square. It means that we are at time t is equal to 0, the velocity is 12 meters per second. After 1 second it will be 13. After 2 seconds it will be 14. Each second it will increase 1 meter per second square. So after 20 seconds, if you continue like this, you are going to get 32 meters per second. Okay, let's look at the formulas, the equations of accelerated motion. In our previous video, it is here, we explained the derivation of kinematic equations, how these formulas, equations are obtained. They are explained in this video. You can go and watch it, or you can YouTube with the derivation of kinematic equations. You can find our video. Now these are the equations, and we are going to use them in solving problems related to acceleration. Then let's continue with another example. A car is moving with 4 meters per second, starts to accelerate at a rate of 2 meters per second square. What will be its velocity after 7 seconds? How long does it travel in 7 seconds? So we are given that v initial is equal to 4 meters per second, and acceleration is given 2 meters per second square, and delta t time is given 7 seconds. So then we are asked to find its velocity. V final is asked. Now from our previous formulas, we know that v final is equal to v initial plus a times t. So v final will be initial velocity is 4 plus 2 is the acceleration times 7. So it will give us 18 meters per second. This will be the final velocity. You can also find the final velocity from the definition of the velocity. For example, the acceleration is 2 meters per second. It means that your initial velocity is 4 and the rate of change of velocity is 2. It will be 6, 8. If you continue like this, you are going to get 18 after 7 seconds. Then let's look at the distance. How long does it travel in 7 seconds? For finding distance, our formula is delta x is equal to v initial times t plus 1 over 2a t squared. Initial velocity is 4 times 7 seconds plus 1 over 2. Acceleration is 2 times 7 squared. If we do this calculation, we will get 77 meters. Okay, let's look at another example. A car traveling at 21 meters per second constantly decreases its velocity to 7 meters per second while traveling 98 meters. Find the deceleration and the time during this motion. What are the givens? We are given that v initial is equal to 21 meters per second, and the final velocity is given as 7 meters per second, and during this deceleration it moves a distance of 98 meters. Then to solve this problem, first of all, for the deceleration, we can use v final square is equal to v initial square plus 2a delta x. Now, final velocity is 7, so 7 square equals initial velocity is 21, 21 square plus 2 times a times 98. If we do this calculation, we will see that acceleration is going to be negative 2 meters per second square. This negative shows that the object is decelerating. Its velocity is decreasing. We can also find we are asked to find delta t. I mean the time. We are asked to find the time. We can find the time from the definition of the acceleration. We know that acceleration is equal to delta v over delta t. So from here we can solve delta t as equal delta v over acceleration. Okay, sorry. So delta v is v final minus v initial, and final velocity is 7 minus initial velocity is 21 divided by acceleration is negative 2. So if we do this calculation, we are going to find 7 seconds. Okay. This is the last question. And a plane lifts off at 150 km per hour. What minimum constant acceleration does the plane must have to take off after a run of 300 meters from rest? How long does it take the aircraft to lift off? Let's first write the givens. Let's write it here for saving the space. The final velocity, the lift-off velocity is 150 kilometers per hour, and acceleration is asked to us. The distance that the plane travels is 300 meters. Initial velocity is given 0 because it says from the rest. Then we are asked to find time also. Okay, in B we are asked to find the time. First of all, let's find the acceleration. We can use this formula: v final square is equal to v initial square plus 2a delta x. Now v final is 150 square equals initial velocity is 0 plus 2a delta x is 300 meters, is going to be 0.3 kilometers. And in calculating this equation, we will get acceleration as 37,500 kilometers per hour square. This is the acceleration of the aircraft. And this is A. For B, how long does it take the aircraft to lift off? To find time, again, I'm going to use delta t is equal to delta v over A. Delta v over A. So delta v is v final minus v initial, which is 150 minus 0 divided by acceleration is 37,500 kilometers per hour square. And if we calculate this value, we will get 0.004 hours. And it will make 0.24 minutes. Then if we change it to seconds, it will be 14.4 seconds. So thank you for listening. See you in the next lesson that we are going to explain the graphs.